Hello everyone, I am Heidi Tricia Santos, and for this video we will be answering one of the problems in double integrals over general regions, which is number 20 on page 10. So let's begin. Here is the problem. Use a double integral to determine the volume of the region that is between the xy plane and f of x y is equal to 1 plus y to the 5th power times the square root of the sum x to the 4th power and 1, and is above the region in the xy plane that is bounded by y equals square root of x equals 2, and the x-axis. So previously, we answered one item regarding the iterated integral over a rectangular region wherein we undergo in double integral and integrate the innermost part depending on the chosen variable to be integrated first, then followed by the other variable. However, for this problem, it will be a bit different since we will be dealing with general regions rather than rectangles. Going back, let's write down the notation. Now, let's take a glimpse of the sketch of the given region to determine the upper and lower boundaries. As you can see, the blue line represents y equals the square root of x. The red line represents x equals 2, and the green line represents the x-axis or y equals 0. On the given problem, we notice that we cannot integrate it with respect to x because the integration by substitution, which will be utilized, is undoable. So, we will reverse the order of integration, which means to say that we will integrate with respect to y first and then x. By looking at the graph, we can say that the limits of y is greater than or equal to 0 but less than or equal to square root of x, and the limits of x is greater than or equal to 0 but less than or equal to 2. Since the upper and lower limits of each variable have been defined, we can now write its defined notation. Then, just like how we solve a double integral, we will focus on integrating the innermost part with respect to y. So the integral of 1 is y, the integral of positive y to the 5th power times the square root of the sum x to the 4th power and 1 is y to the 6th power times the square root of the sum x to the 4th power and 1 all over 6. And now, since we are done with integration, we will evaluate this from 0 to square root of x. So let's replace all y with square root of x, then after the minus sign, replace all y with 0. Then do some basic arithmetic. We have arrived at having the definite integral of square root of x plus x cubed times the square root of the sum x to the 4th power and 1 over 6 from 0 to 2. So now, let's apply one of the properties of double integral, wherein the integral of a sum is the sum of the integrals. Next, we can rewrite square root of x as x raised to 1/2 for easy integration. Meanwhile, x cubed times the square root of the sum x to the 4th power and 1 all over 6 will undergo integration by substitution. And here is the process. So on the second term, we end up having square root of u over 6 times du over 4. From here, we can just move the constant, which is 1 over 24 outside. Proceed with actual integration. The integral of x raised to 1/2 is x raised to 3 over 2 all over 3 over 2. And the integral of square root of u is u raised to 3 over 2 all over 3 over 2. So now let's just further simplify this before we evaluate it. So after we have polished our work, we can now evaluate this from 0 to 2. Again, let's replace all x with 2. Then after the minus sign, replace all x with 0. So let's polish our solution by performing some basic arithmetic. And that's it. The volume under the given function over the non-rectangular region is 48 square root of 2 plus 17 square root of 17 minus 1 all over 36. So that's all for this video. Have a nice day ahead!